In our last chapter, we understood a lot about human brain. In this chapter, we'll learn a lot about artificial neuron. Right? So, real neuron versus artificial neuron. So now we all know neurons receives the signal. A signal can be a strong or weak, and it decides where it adds up to the incoming signal. If enough strength is there, then it fires, and then it sends the output. It sends the signal through the axon, and it affects the other neurons. So this is how a neuron works, is what we understood when it comes to real neuron. So when it comes to artificial neuron also is designed in similar to the real neuron. This also has 3 parts, right? So the first part is input, and the second part is weight, and the third part is output. So now when you take an example of input, weights and output, so for an input you can consider the numbers, right? So when I say number, it can be like pixels, or it can be a temperature, right? And weights. What are weights, right? Weight is that which evaluates the importance of that input. So whatever the input we are assigned, so it evaluates that importance of that input. So what is output, right? Output combines the input, produces one output number. So it combines the input, the weights assigned to those input, and it produces a single number, which will be an output. So the decision process. So how is that decision process which happens now? Right? So the decision process is the signal in our brain into synapse strength, right? As I mentioned, it can be a strong synapse, it can be a weak synapse. Into the signal is the sum where you get, which decides whether it should fire or not to a nearby neurons. So this is what it happens when it comes to AI. How can we compare the same with the AI? So AI also in the same way input, and you'll have a weight which is summing up, which decides should the output be given or not. So this is when it comes to our brain, and this is when it comes to our AI, artificial intelligence. So now we were talking about activation, right? So firing in AI. So what is activation, and when it comes to brain, how, and when it comes to AI? So neurons fire if the signal is strong enough. That we discussed. And when it comes to AI, the activation function will output something, or should it stay quiet? So now when it comes to here, it should fire or not, and when it comes to AI, should it output or not? And learning. So coming to the brain will develop a useful connections if it's strongest, and useless connections if the neuron connectors are weaker. Right? When it comes to brain, right? So here if it is useful connections, we'll keep it, they will be stronger, and if it is useless connections, then it will be weaker. Whereas in AI, how are we doing? So if it is a good prediction, or if it is a bad prediction. So what happens if it is a good prediction, right? The weight, whatever we keep, we'll keep the same weight if it is a good prediction. If not, we change the weights. So now for the quick comparison, with the brain neuron and artificial neuron. So brain neuron is chemical plus electrical, whereas AI neuron is completely mathematical. So just to have a quick depiction about the comparison. So quick comparison, brain neuron and the AI neuron. It is chemical and electrical, whereas AI neuron, it is mathematical. When it comes to brain neuron, it learns naturally, right? So our brains learn naturally, and AI neuron, it learns by training. It learns by training. And now our brain cells or brain neurons are self-organizing. So they are capable of organizing themselves, whereas in AI neuron it is human designed. So these are all the major differences when it comes to AI and our brain neuron. So now coming to understanding the neuron and its structure and aligning with to the AI neuron, we understand a lot of things here, right? How artificial intelligence is getting developed, whereas with respect to our brain. Now, neural network. So since real world problems are complex, one neuron is not enough for us, right? Same as brain. Even in brain, a single neuron doesn't do all the job. We have billions of neurons. In a similar way, in our AI world, a single neuron is not enough. Intelligence comes from the network and not a single cells. So a neural network is the one. So what is this neural network? So neural network is the one which is a group of artificial neurons connected in layers that learns the pattern from the data. And that combination or that group of artificial neurons, we term it as neural network. So now we understood that a group of artificial neurons are responsible and they learn the pattern. And how they learn in a layers, and once they learn from the data, the pattern, they'll be able to kind of analyze the data. So now what are all the layers? Correct? So when it comes to what are all the layers, we have input layer and hidden layer and output layer. So input layer is nothing but it's where the data enters. So it's where the data enters. And each neuron represents one feature. Okay? And input neurons don't think, they pass the data. So they don't make any decisions or they don't analyze anything. All they do is just pass the data. For example, you can consider a pixel value in an image, right? And also in a student marks, you can consider a subject marks of a student. So these are all just an input layer, which is a starting layer where the data enters and each neuron is considered to be a feature. For example, as I mentioned, in an image, a pixel value can be an input layer. So what is a hidden layer, right? Hidden layer can be as number of layers it wants to be, depends on the complexity of the problem, and then it combines the input, it finds the pattern, and it creates the representation. So where it can be more hidden layers too, right? Hidden layer is very core of the problem solving neural network layer. It will combine the input and it will find the patterns and create the representation. If you want to understand with respect to brain analogy, it is like an intermediate brain areas that detects the shapes or edges of the meaning, right? Even our brain learns the pattern. When you touch something which is book, the brain understands that it is a square shape. So as I mentioned, hidden layer can be more layers. And what is output layer, right? That gives the final output. So output layer is something which gives a final output. A final output can be yes or no, or it can be a category like anything, right? It can be like a cat or dog which says after seeing an image, or it can be a number. When I say number, it can be a price or maybe a temperature, it can be anything. So this is an output layer. And trust me, all of this you will understand in a very better way with the real-time examples, which will go into our next chapters and we'll learn them. But here, for a basic, it is important to understand all these factors with a real-time analogy too. Right? So basically the information is flowing here. It is how it is flowing. It is flowing from input to hidden and hidden to output. And this input flowing is called forward propagation. Okay, so very important term, forward propagation. Okay. Now, does every time machines act so right and give right answers? Definitely no, right? So, machines too learn from mistakes. That is a very, very core concept of machine learning. So, when machines learn from mistakes, it compares the output with the right answer and it measures the error and it adjusts the weight to reduce the error, which we spoke about in the previous classes. So machines do learn from mistakes, right? Machines learn from mistakes, which is very important for us to understand. So now we spoke a lot about neural network. There will be layers in this and forward propagation. So if we give an example, it will be better for you all to understand. Let's take an example of face recognition. So we have an image and we want to recognize the face in it. What all can be the layers? A layer 1 can be an edge lines, a layer 2 can be a shapes, a layer 3 can be a face structure. So as many layers as possible it can have in a hidden layer. Whereas input layer, it will be the values of pixels. And at the output layer, we can just tell if a face is recognized or not. If you take an example of an image of a dog, input layer can be a data which enters, which the features or the pixel values. A hidden layer can be the edge lines or the shapes or how the face structure of a dog is. And the output layer will be a category which can be dog. So this is what is the neural network is all about. So now we understood neural network and we compared with the brain neuron, AI neuron. So where does this neuron, learning about artificial neuron, comparing to a human brain, how is all this working, right? So where exactly this falls under machine learning or artificial intelligence domain? Is everything is about neuron and the ways it is working? Definitely no. There is a lot of categories under which the artificial intelligence is branched into based on dimension. So artificial intelligence, one of the domain is the deep learning, which has this neural network. So it was very important for us to kind of understand all this which will give us as a base. But in our next chapters, we understand in detail about the AI branches, where exactly the neural network falls into, and what exactly is the other, branches of AI. So how exactly we can categorize AI to understand in a very clear manner. We learn all that in our next chapters. Hope you gained the basic knowledge about neural network in this chapter, and in our coming classes we'll understand and solve a lot of neural network problems when we come to that topic. For now, in our next chapter we'll learn about AI branches based on dimension. Thank you all.